So we start our hazard analysis techniques by talking about functional hazard analysis. It's a technique that should be performed early in the system life cycle, but generally after the concept definition phase. So as such, it will most likely not be the first analysis technique used, but it is good for our introductory technique because it's well-rounded and it's not really a difficult technique to employ. So functional hazard analysis technique should be used during the development phase of the system life cycle. Generally, it's a technique used with preliminary design and system design hazard analysis types. It's when you know enough about the system to know some functions, but not so much detail as is required with some of the other techniques. At the end of the functional hazard analysis, the outputs, or the purpose of the technique, is to identify safety critical and safety related functions and items, and we talked about those in depth in the previous video. So here's the worksheet. FHA is documented on a worksheet, and you're given examples in your text about an ACE missile and a couple of other examples, and it's very good detail in your text. I also put a sample worksheet, FHA worksheet, in Word format in your course resources section of your online learning tool. So in PowerPoint 6, I give us an example of a go-kart, and so we'll work through that just briefly here. It's the go-kart FHA example. It's not an all-inclusive example, but designed to really just give us the principles, give you the principles behind the functional hazard analysis technique. The function column here comes straight from the system functions that are given in the engineering document. So steering, acceleration, and braking, in this case, those are the functions in this first column, the function column. All right, in the hazard column, we identify the hazard. For functional analysis, it is important to use the hazard checklist for failure states. This gives us a list of failure states, and in an attempt to keep this example simple and straightforward, I did not put all of the failure states that are possible for each of our three functions. Just keeping it simple and straightforward. A more detailed example is given, though, in your text. But these are just some examples from our go-kart example. So in our checklist, fails to operate would equate to, in our steering, fails to steer. In acceleration, same thing, inability or failure to accelerate. We also have operates incorrectly or erroneously, inadvertently, at the wrong time, unable to stop operations. So we have an unable to stop acceleration as one of our hazards. So we went through this hazard checklist of failure states in order to generate or give us some mental triggers as to what hazards might be for each of our three functions. Now I go through each of the columns in detail in PowerPoint number 6, but here we're just going to go through the ones that are a little bit more critical, and I wanted to point out here that there are three columns for the hazard. We have hazard, effect, and causal factors. These three columns, do they look familiar? They should. Hazard equates to the hazard source, the HS component of the hazard. Effect equates to the TTO, the target threat outcome, and the causal factors equate to the initiating mechanism. So your three components of the hazard are all represented here in the functional hazard analysis worksheet. It's important to recognize that. Once we've identified the hazard, the three components of the hazard, we now move to the IMRI, the Initial Mishap Risk Indicator. This is the risk indicator prior to mitigation. So it's before mitigation. We use the severity and the probability definitions from MILSTD 882 or other specific definitions, but whatever definition you use, be sure to use the same definitions throughout the entire process. Those definitions for severity and probability are recommended, and they're in the government document, the MILSPEC 882. They can be adaptable to your particular system. The important thing is that throughout the functional hazard analysis process, you use the same definitions to show consistency. We will use those given in the MILSPEC. You see the severity identified by the number and the probability identified by the letter. Also note, severity 1 or 2 would be considered safety critical, while severities 3 or 4 would be considered safety related. So we're well on our way to recognizing what our goals are of the functional hazard analysis, and that is to identify safety critical functions and items and safety related versus safety related items and functions. Mishap risk indices can be plotted on a risk matrix to give us a visual indication of that risk level and acceptability. So in our example, our first identified hazard, fails to steer, has an initial mishap risk indicator of 2B. That's a 2B, critical, and B, probable. So we're here, it's a high risk. So we can do that going down through our initial mishap risk indicators to plot them on the chart and see exactly where our priorities might lie. The next column, recommended action, is what should be done to reduce or eliminate the hazard. Be sure to work through recommended ideas in the hazard reduction order of precedence. Remember that from earlier PowerPoints. It is much more reliable to design out hazards or to design in safety measures rather than to provide safety procedures or practices. Sometimes you cannot work it through design, but especially in these early phases of the system life cycle, it's important to try to consider as much design safety as we can. Next, given the implementation and testing of the recommended action, what would be the final mishap risk indicators? The final mishap risk indicators, this is generated just like the IMRI, the initial indicator. It uses the same definitions and codes for severity and probability. And generally, unless risk mitigation efforts are designed to make a crash more survivable, the factor that generally adjusts is actually the probability. So you see here, as we implement recommended actions, our steering, for example, failure to steer has gone from a risk indicator of 2B to 2D. So the 2, the critical, stays the same. It went from probable to remote if we put in a backup reservoir and do a pre-drive inspection. Notice that the backup reservoir is a design function. The pre-drive inspection are procedures. The priority being design in a backup reservoir and then add procedures if we need to. So that was a quick overview of the functional hazard analysis. There's examples given in our text. I did not highlight every column in this video, but the ones that needed a bit more explanation. All columns are addressed in your PowerPoint number 6. The end goal, though, of the functional hazard analysis is to be able to identify safety critical and safety related items and functions. Final mishap risk indices or indicators with 1 or 2 in the severity are deemed safety critical. Here are your safety critical items, 2s and the 1s. Okay, so these are your safety critical functions. Safety related, these actually we decided there wasn't going to be any energy, not a safety concern there. This would maybe be a safety related function. So those are the top priorities. The safety critical items, that is, are the top priorities. The safety requirements that that resources should focus on to try to mitigate those hazards. Next, we're going to start into some of the earlier hazard analysis techniques.